Imagine trying to grow food on a 60-degree slope at 12,000 feet above sea level, where the air is so thin you can barely breathe, and one wrong step sends you tumbling thousands of feet to your death. Now, imagine not just surviving in this environment, but creating a food surplus that feeds millions of people. The Inca civilization accomplished something that would challenge even our modern agricultural engineers today. While we struggle to grow crops on flat, fertile plains with all our advanced machinery and chemical fertilizers, the Incas transformed the steep rocky slopes of the Andes Mountains into some of the most productive farmland in human history. But here's what most people don't realize about this incredible achievement. They didn't just figure out how to farm mountains. They actually made the mountains better at producing food than the valleys below. These weren't just desperate people trying to scratch out a living on marginal land. The Incas developed a sophisticated system of mountain agriculture that was so effective it could support a population of over 12 million people across an empire that stretched for thousands of miles along the world's second highest mountain range. They turned environmental challenges that would defeat most civilizations into competitive advantages that made their empire possible. The scale of this transformation becomes mind-blowing when you consider the terrain they were working with. The Andes Mountains rise from sea level to over 22,000 feet in elevation, creating an environment where temperatures can vary by 50 degrees within a few miles of horizontal distance. Most of the slopes are too steep for conventional farming, the soil is thin and rocky, and the weather can shift from blazing sun to freezing hail in a matter of minutes. Yet the Incas didn't just adapt to these conditions. They engineered solutions that turned every disadvantage into an opportunity. They created microclimates where none existed, built soil where there was only rock, and developed water management systems that could irrigate crops on near vertical slopes. Their innovations in mountain agriculture were so effective that many are still used by Andean farmers today, more than 500 years later. The Great Wall of Farmland, Terracing, Andeans. The most famous Inca farming innovation was their terracing system, known as Andeans, which transformed steep mountainsides into stepped agricultural platforms. But these weren't just simple stone walls holding back dirt. They were sophisticated engineering systems that created entirely new agricultural environments on slopes that seemed impossible to farm. Inca terraces were built using a multi-layered construction technique that would impress modern civil engineers. The foundation consisted of large stones carefully fitted together without mortar, creating a retaining wall that could flex during earthquakes without collapsing. Behind this wall, the Incas built a complex drainage system using progressively smaller stones, gravel, and sand that prevented water from building up and causing landslides. The construction process for these terraces was incredibly labor-intensive but remarkably effective. Teams of workers would first identify suitable slopes and plan the terrace layout to follow natural contours and drainage patterns. They would then quarry stones from nearby sites, shape them to fit precisely, and transport them to the construction site using human labor and ingenious lifting techniques. Each terrace level was carefully engineered to be perfectly horizontal, creating flat planting surfaces on slopes that could exceed 60 degrees. The width of individual terraces varied depending on the steepness of the slope and the intended crops, but most were between 3 and 15 feet wide. The vertical walls between terraces were typically 3 to 6 feet high, creating a stepped appearance that maximized usable farming area. The soil creation process for these terraces was as impressive as their construction. The Incas couldn't just fill their terraces with local soil, because mountain slopes typically have very thin, rocky soil that's unsuitable for intensive agriculture. Instead, they created artificial soil by combining materials from different elevations and environments. Fertile soil for the terraces was created by mixing highland clay, lowland organic matter, and carefully composted materials. This artificial soil was often more fertile than natural valley soils because it was specifically engineered to provide optimal growing conditions for different crops. The Incas understood soil chemistry well enough to create custom soil mixes for different types of plants. Hidden irrigation systems. The irrigation networks that supplied water to Inca terraces were marvels of hydraulic engineering that rivaled anything built by contemporary civilizations. These systems had to move water across incredibly difficult terrain, often carrying it for miles along mountainsides and up steep slopes to reach the highest agricultural areas. Water sources for these irrigation systems included mountain springs, streams, and even seasonal snowmelt that was captured and channeled through stone-lined canals. The Incas built these canals with precise gradients that maintained steady water flow without causing erosion or overflow. The engineering tolerances were so tight that many of these 500-year-old irrigation channels still function perfectly today. The distribution system within terraced areas was particularly sophisticated. Water would enter at the highest terrace and flow from level to level through carefully designed spillways and channels. This cascade system ensured that every terrace received adequate water, while preventing any single level from being flooded or washed out. Flow control was achieved through a system of removable stone gates and wooden channels that allowed farmers to direct water to specific terraces as needed. During planting and growing seasons, water could be distributed evenly across all levels. During harvest or fallow periods, water could be diverted to other areas or allowed to flow through without irrigation. The perfect drainage system. The drainage engineering built into Inca terraces was as important as the irrigation systems, because poor drainage could destroy months of work in a single heavy rainstorm. The Andes receive intense seasonal rainfall that can quickly overwhelm agricultural areas, and the steep slopes make erosion and landslides constant threats. Subsurface drainage was achieved through the layered construction technique used in terrace walls. Behind the visible stone retaining wall, the Incas built a sophisticated filter system using progressively smaller materials. Large stones at the back allowed water to flow freely, while smaller stones and gravel filtered out soil particles that could clog the drainage system. This drainage layer extended across the entire width of each terrace, creating a continuous underground drainage network that could handle even the heaviest rainfall. Water that seeped through the soil would be collected by this system and channeled to controlled outlet points where it could flow safely to lower levels without causing erosion. Surface drainage was managed through carefully designed spillways and channels that directed excess water away from planted areas. These channels were lined with stones to prevent erosion and were sized to handle the maximum expected water flow during the heaviest storms. The guano secret, natural fertilizer. The Incas discovered and perfected the use of guano, the nitrogen-rich droppings of seabirds, as a powerful natural fertilizer that could dramatically increase crop yields. This discovery was so important that the Inca government strictly controlled guano collection and distribution, making it a state monopoly that helped fund the empire. Guano collection was a specialized occupation that required workers to travel to remote coastal islands where millions of seabirds nested. These workers, known as guano collectors, would carefully harvest the accumulated bird droppings using simple tools, then transport it back to the mainland for distribution throughout the empire. The transportation network for guano was extensive and well organized. Llama caravans would carry loads of this precious fertilizer from the coast up into the mountains, following established trade routes that connected coastal collection sites with highland agricultural areas. The logistics of moving thousands of tons of fertilizer across such difficult terrain required sophisticated planning and organization. Application techniques for guano were carefully developed to maximize its effectiveness. The Incas learned that fresh guano was too concentrated and could burn plants, so they developed methods for aging and diluting it to create optimal fertilizer mixtures. They also discovered that different crops responded better to different concentrations and application methods. Controlling microclimates. The microclimate management achieved through Inca terracing was one of their most sophisticated agricultural innovations. By creating terraces at different elevations and orientations, they could grow a wide variety of crops within a relatively small geographic area, taking advantage of the natural temperature and moisture variations that occur with changes in altitude. Elevation zones were carefully planned to match specific crops with optimal growing conditions. Maize could be grown on lower, warmer terraces, while potatoes thrived on higher, cooler levels. This vertical farming approach allowed the Incas to produce diverse crops within walking distance of each other, creating food security through agricultural diversity. Orientation effects were also carefully considered in terrace design. South-facing terraces received more direct sunlight and stayed warmer, making them ideal for heat-loving crops. North-facing terraces stayed cooler and retained moisture longer, providing better conditions for crops that preferred cooler temperatures. Stone walls of the terraces acted as thermal mass, absorbing heat during the day and releasing it at night. This helped moderate temperature swings and extend growing seasons, allowing crops to survive occasional frosts that would otherwise destroy them. The thermal properties of the stone walls effectively created artificial microclimates that were more stable than the surrounding natural environment. Vertical farming, the Moray mystery. The Moray Agricultural Laboratory represents one of the most sophisticated examples of Inca agricultural experimentation. This site consists of a series of concentric circular terraces that descend into the earth like a giant amphitheater, creating distinct temperature zones that allowed the Incas to test crops under different growing conditions. Temperature gradients at Moray create microclimates that can vary by as much as 15 degrees Celsius between the top and bottom terraces. This temperature difference is equivalent to moving several hundred miles north or south, allowing the Incas to simulate growing conditions from different parts of their empire within a single experimental site. Crop experimentation at Moray likely involved testing new varieties of potatoes, maize, and other crops to determine which varieties performed best under different conditions. This research would have been crucial for an empire that spanned multiple climate zones and needed to ensure food security across diverse environments. Research methodology at sites like Moray demonstrates the sophisticated scientific approach that Inca agriculturalists took to crop development. They understood the importance of controlled experimentation and systematic observation in developing new agricultural techniques and crop varieties. Foot plows and simple tools. The chacatakala, or Inca foot plow, was a deceptively simple tool that was perfectly adapted to mountain agriculture. This implement consisted of a wooden shaft with a bronze or hardwood point and a footrest that allowed the user to drive the tool into the ground using leg power rather than just arm strength. Tool design of the chacatakala was optimized for working on steep slopes and in rocky soil conditions where conventional plows would be useless. The pointed end could penetrate hard ground and work around rocks, while the footrest allowed farmers to apply their full body weight to drive the tool into difficult soil. Planting techniques using the shakatakala were highly efficient and well adapted to terrace farming. Farmers could quickly create planting holes at precise spacing and depth, then drop seeds into the holes and cover them with a few quick motions. This technique was much faster than digging individual holes with hand tools and more precise than broadcasting seeds. Soil preparation with these simple tools was surprisingly effective. Teams of workers using shakatakalas could break up compacted soil, incorporate organic matter, and prepare planting beds on terraces that would be impossible to work with animal-drawn plows or modern machinery. Freeze-drying food to store it, chunyu. The chunyu preservation technique was a brilliant solution to the challenge of storing food in an environment with extreme temperature fluctuations. This process used the natural freeze-thaw cycles of high-altitude environments to create freeze-dried potatoes that could be stored for years without spoiling. Processing method for chunyu involved exposing potatoes to repeated cycles of freezing and thawing over several days. The potatoes would be left outside overnight to freeze solid, then trampled during the day to squeeze out the water that had formed ice crystals. This process was repeated until all moisture was removed, leaving behind lightweight, shelf-stable food. Storage capabilities of chunyu were remarkable for a pre-industrial society. Properly processed chunyu could be stored for 10 to 15 years without spoiling, providing crucial food security during crop failures or other emergencies. This long-term food storage capability was essential for supporting large populations in an environment where crop failures could occur due to weather, pests, or other factors. Nutritional value of chunyu remained high despite the processing, retaining most of the protein, carbohydrates, and minerals of fresh potatoes. The freeze-drying process actually concentrated some nutrients, making chunyu a valuable food source that could sustain people through long periods when fresh food was unavailable. The power of public service, Meita. The Meita labor system was the organizational innovation that made large-scale mountain agriculture possible. This system required all able-bodied citizens to contribute labor to state projects, including the construction and maintenance of agricultural terraces, irrigation systems, and storage facilities. Labor organization under the Meita system was highly efficient and well coordinated. Communities would send workers to participate in major construction projects during agricultural off-seasons, ensuring that farming activities weren't disrupted, while still providing the massive workforce needed for infrastructure development. Skill specialization within the MITIA system allowed for the development of expertise in different aspects of mountain agriculture. Some workers specialized in stone cutting and terrace construction, others in irrigation system maintenance, and still others in soil preparation and crop management. This specialization improved the quality and efficiency of agricultural infrastructure. Community investment created through the MITAI system ensured that everyone had a stake in the success of agricultural projects. Since all community members contributed labor to building and maintaining the agricultural infrastructure, everyone benefited from increased food production and improved food security. The crop rotation system. The crop rotation practices used by Inca farmers were sophisticated systems that maintained soil fertility and prevented pest buildup while maximizing food production. These rotation systems were based on centuries of observation and experimentation with different crop combinations and sequences. Soil fertility management through crop rotation involved alternating nitrogen-fixing legumes with heavy-feeding crops like maize and potatoes. This natural fertilization system maintains soil productivity without requiring external inputs, making it sustainable over long periods of intensive cultivation. Pest control through crop rotation disrupted the life cycles of insects and diseases that were specific to particular crops. By changing crops regularly, farmers could prevent the buildup of pest populations that could devastate monoculture plantings. Fallow periods were incorporated into rotation systems to allow soil to rest and recover. During fallow years, terraces might be planted with soil-improving crops, or left unplanted to allow natural vegetation to restore soil organic matter and structure. The legacy of Inca mountain agriculture. The agricultural innovations developed by the Incas continue to influence farming practices in the Andes today. Many of the terraces they built are still in use, and their techniques for managing mountain agriculture remain relevant for modern farmers facing similar environmental challenges.